Hello everyone, Happy New Year. You're welcome to my channel, Microsoft Project Simplified. My name is Dennis Mora. Today's tutorial is tutorial number 4, part 2. It's the continuation of the previous tutorial, which was number 4, part 1. And we are still on the scheduling, our sample project. In the previous tutorial, we ended at entering the duration for the task. And so far, we have entered duration for 2 tasks. That is the personnel. We have given it 21 days and equipment. Today, we are going to continue with entering duration for the task from material up to the last part of it, which is the handover. Previously, we have talked about how do you decide to give the duration for a task when you're doing scheduling. One should have the idea of the output of the resources available. How much can they do in a day or in an hour, so that you can estimate the duration for each task. Not forgetting adding 20% buffer to the duration you have estimated. The 20% buffer always take care of unforeseen circumstances. That is very important. So let's continue. Okay, we have material. We are going to give it 90 days. And we go to site camp establishment. We are giving it 45 days. We have access to site camp, borrow pit, and other material sources. We are going to give 15 days. We have road alignment and data collection. We are giving it 40 days. We have detailed design. We are giving it detailed design. We are giving it 120 days. Okay, 120 days. We have design review and approval. We are giving that one 18 days. 18 days. We have clearing and grabbing. Clearing and grabbing, we are giving it 50 days. We have removal and grabbing large trees and stumps. Here there is let me correct this, large trees, not largest trees. Large trees and stumps, we are giving it also 50 days. Topsoil stripping, we are also giving it 50 days. The reason we are giving these 3 items 50 days each, they always move together. If you look at clearing and grabbing, removal and grabbing, large trees and stumps, topsoil stripping, they always move together. So they should take same days. We have common excavation to spoil. Common excavation to spoil, we are giving it 35 days. Roadbed preparation, we are giving it roadbed preparation 65 days. Drainage excavation, we are giving it 70 days. Okay, we have G7 material, G7 quality fill material. We are giving it G7. We are giving it 130 days. G15 quality material fill on the upper subgrade. We are giving it G15. We are giving it 45 days. We have excavation and bed preparation for pipes culverts. We are giving it 60 days. Pipe installation. Pipe installation. We are giving it 32 days. Concrete and casing for the pipes. We are giving it concrete and casing 40 days. Backfilling of culverts. We are giving it backfilling 80 days. 80 days. Construction of end structures. We are giving it 45 days. Then we have natural gravel. This should be G30 for wearing course. We are giving it 35 days. 35 days. We have checking works and clearing. We are giving it 14 days. 14 days. Demobilization. We are giving it 12 days, and another 1 day. I think we skipped something here. G15. It was not. G15 was supposed to be 45 days. 45 days. Okay. Now, like this. Now, after entering the duration for each task, you can see on your right-hand side how the Gantt chart is extending. The way it's extending here, you can see that the start date is all 21st of November. They all have the same start date. This is because we have not done the fine-tuning in our schedule. But if we have done the fine-tuning, they will not have the same date. Some of them will have the same date, some of them will have different dates of starting. And also on the right-hand side here, things will change. But we are going to that one in the next stage. Now, I want you to take a look here. If you look at mobilization, you may ask yourself why we have not given the duration for mobilization. Why we have not given the duration for preliminaries. Why we did not give the duration to survey and design. The only reason here is, if you look at the task below, take example preliminaries. You have two tasks below preliminaries. When we reach the stage of indenting the task, the duration for preliminaries will come up here automatically. Actually, is the summary of the days for these two activities, which will be shown here. So we don't need to worry about that. We just need to wait for the time of indenting, you will see that this one day will change. Change as these two, okay, it will be like the summary of these two tasks. Summary of days for the two tasks will appear here. That is how it works. So don't get worried about that. Okay, it's fine. Now we have entered all the duration for the task. The next things we're going to do is to do the fine tuning of our schedule. But before we do the fine tuning of our schedule, we need to go through the common terms used when we are doing the fine tuning. And because of that, let me first close this and we go through those terms. Okay. These are the key terms used in fine-tuning schedule in MS Project. Predecessor task. This is a task whose start date is a task whose start or end date determines the start or the finish date of another task. It's brief, but when we come to the actual reusing of these predecessor task and successor, things will get very clear. The second definition here is the successor task. This is a task whose start date or the finish date is driven by another task. And this another task is always the predecessor. If you can, we have just said a predecessor is a task whose start or end date determines the start or finish date of another task. So this is something which we are going to see when we come to fine-tuning our schedule. The third one is dependency. Dependency is a link or relationship between a predecessor task and a successor task, how they relate to one another. And we are going to see what kind of relationship which exists between the predecessor and the successor. Dependency controls the start or finish date of one task relative to start or finish date of the other task. The most common dependency is finish to start, denoted by FS, in which the finish date of the predecessor task determines the start date of the successor. Actually, in MS Project, this type of the kind of dependency, finish to start, is set as a default setting. But it's not only this. Now we're moving to the next one. Types of dependency. There are 4 types of dependency in MS Project. The first one is what we have been talking about, which is finish to start. In this case, the finish date of the predecessor task determines the start date of the successor task. Example, if we are doing the clearing, let us take 2 examples or 2 activities, clearing and grubbing and roadbed preparation. You cannot start roadbed preparation when clearing and grubbing is not complete. So we can relate clearing and grubbing and roadbed preparation to this kind of dependency. So meaning you finish clearing and grubbing so that you can start roadbed preparation. The second type of dependency is start to start. This means that the start date of the predecessor task determines the start date of the successor task. Let's consider clearing and grubbing, removal of large trees and stumps can be a good example here. When you start clearing and grubbing, you also start removal of large trees and then the stumps. So it means you start clearing and grubbing so that removal of large trees and stumps also should start. That is how it means. The third one is finish to finish. This means that the finish date of the predecessor task determines the finish date of the successor task. This kind of dependency is not very common. I don't have a straight example right now, but as we move on, I'm sure we shall find one and we shall understand it well. The fourth one is start to finish. It means the start date of the predecessor task determines the finish date of the successor task. Also, this fourth one is not very common, and I don't have a direct or very clear example right now. But as we move on, we shall get a clear example somewhere, and then we shall use it. This is not all. We are still moving forward. We have lag time. Lag time is the intentional waiting period added to the predecessor task before a successor task can start or finish. It is expressed as a positive time value. Example could be when the design is complete. Normally, there is a time given for review and approval. So, certain time is added after completion of the design for the review and approval to get done. After that, the actual execution can start on the ground. We have also late time. Late time is the overlap between two linked tasks, and late time allows the successor task to start or finish before predecessor is completely done. It is expressed as a negative time value. I would cite example like this. In our case of this sample project, we have over 10 kilometers of road. We cannot do the clearing and grubbing in the 20 kilometers and then we come back to start road bed. It's not practical. So here, to relate clearing and grubbing and road bed, you can do clearing and grubbing up to some extent. Then you can start doing the road bed. Now, to do this, first of all, you need to have a kind of relationship between the two tasks. Then you introduce what we call the late time, so that you can start your road bed before clearing and grubbing is completely done. This is how it works, and we are going to handle this when we are doing our final or doing the fine tuning in the scheduling. And okay, this is the key terms I wanted us to go through. Let us go back. Let us go back to okay. So this is our schedule. Now, the next thing now, we need to do the fine-tuning of this schedule. And we shall do this in our next tutorial. For now, we are stopping here. And I would like to thank you very much for watching this tutorial. See you in the next tutorial. Bye-bye.